And that should be in the public domain. It's a fundamental. Like if taxpayers are paying for something, it shouldn't just be locked away or commercialized or hidden away on someone's computer and never seen again. If it's shared with people, then we can get the most benefit out of that.
Welcome to another episode of the Bioinformatics Lab podcast. I'm Kevin Libwitt, again with Andrew Page. We're from Theogen, and today we're talking about the utility of open source software in the world of public health pathogen genomics. Not only the utility, also maybe touching on some of the challenges with working on strictly open source software. So obviously, this is a world we work very deeply in, and a big proponents of open source, transparent, accessible resources. Andrew, what are your thoughts on that? To kick us off on, let's start on the utility side of open source software. Why is it important that software be made open source in the world of public health pathogen genomics?
Yeah, well, I guess I've written an awful lot about open source software, and it's on GitHub if you want to check it out. And I know, Kevin, you've dabbled in quite a bit as well. So, we come from a position of strength there. And what is most important, I think, for what we do is the reproducibility aspect. You don't have to fiddle around and reinvent the wheel. You can just take something someone has done and then just download it and run it. And you don't have to worry about restrictions or paying money or licenses. It just kind of works. And that's the great thing about it. So it's reproducible, it's free, and you can extend it so you don't have to reinvent the wheel. You can just say, well, I want an extra piece on top of that, so I'll just add a little piece. You harness a community of practitioners out there who actually use the software, and so they can contribute fixes and you can make it even better. So overall, everyone kind of wins, and it means that we get better, higher quality software quicker.
I love exactly what you're saying, because it becomes community built. There's a number of practitioners who can access those same resources, not only to just rerun what you've already built, but also build upon it. Go in and tinker and find the nuances that might help to either optimize things or add functionality to these different resources so that it can expand those capabilities. And reinventing the wheel is a big part of it. There's actually, I would say, sometimes when you're first getting in the field, even in academia, a lean to wanting to almost reinvent the wheel. It's like, oh, let me learn how to write my own workflow to do this same task. But often, I think what people quickly find is that, if you are sequencing E. coli for the first time and doing something like whole genome sequencing, you don't have to start from scratch. There are a lot of processes that are set in stone that are best practices for, processing that data, ensuring there's quality control around the raw data going into something like a de novo assembly, and then even, characterization at the genus, species, or even like subspecies level for E. coli. So you can start at a pretty high rung in the ladder by adopting a lot of open source tools, as opposed to, maybe trying to write your own de novo assembly, which is a task that maybe some people want to take. And we still need a lot of the specialized algorithm people in the world to be able to keep pushing that boundary forward. But that's not necessarily the intent, I think, of most public health laboratories, especially. What they want to do is capture those best practices and be able to run that analysis in their public health laboratory.
And we're in a field that's actually quite unique in that sense, where everything from the beginning was open source. If you look at other fields, people use MATLAB and other closed source software, which costs an absolute fortune. For every little component, you have to pay another huge fee, and it really restricts what you can do. And I remember one of the early projects I was doing was people have written some stuff in MATLAB, and sure, it's cheap for education, but not for anyone outside education. And the idea was we'll create a binary and then, we'd see, and then you interact with it and you add on stuff and it'll all magically work. But still, to actually compile it, you need to purchase a copy of MATLAB, which is quite a huge constraint for people if it costs thousands upon thousands of pounds or dollars. And so that's not really a feasible thing. Whereas if you are able to just go and download a compiler, build your own software, interact with it, extend it, it's not an issue then. You can do quite a bit with that.
That's a huge part of it. The barrier to access, especially again in the world of public health, there's a lot of low resource settings where they might not have those, thousands of pounds for to buy a license to necessarily access resources that they critically need. And that's, I think, another component of this is in public health, laboratories need some kind of standardized way to analyze their data. And if that standard approach is, you know, cost prohibitive, people are going to just inherently look for other kind of resources, and you won't have a standardized approach. And if it's not something that can be replicated outside of that proprietary machine or proprietary software, that you are seeding non-standardization, especially, of course, we all learn the lessons of COVID-19. We need, or at least there is a huge value in having a standardization of the analytical approach itself, especially when it comes to um, the workflows, how data is actually being processed, interacted with, and interpreted as well. People need to see exactly how that's happening in one country versus the next country as well.
And of course, a big key aspect in our field is actually a lot of work is funded by government or funded by charity, and that should be in the public domain. It's a fundamental. Like if taxpayers are paying for something, it shouldn't just be locked away or commercialized or hidden away in on someone's computer and never seen again. If it's shared with people, then we can get the most benefit out of that. But following on from that, then is the type of license, open source licenses that are applied. And that's a bit of a minefield, actually, because people have their own different preferences, and some are very, very permissive. You can do basically anything you want. Others are very restrictive, and some are very political. So it's quite a difficult thing to get right, and yet to navigate it. Sometimes you need lawyers involved to actually understand. Can I actually do this little thing that seems so trivial? Can I connect these components? And I was like, maybe not.
Oh man, that is such its own kind of not black box I was going to say, but like Pandora's box maybe of like the different licenses, because I feel like every time it's one of those subjects that I almost completely forget about in terms of the nuances between the different licenses until I have to have that discussion again. I have to bring up all the different forms of like, okay, what's GNU versus the MIT versus X, Y, and Z. So how much of that material do you have in your head and ready at the helm to be able to speak about? Like, do you have a preferential license, and what
I do.
reason? Okay, well, yeah, please speak
So
on that.
my default is GNU GPL3, right? It's it's what a lot of people use. It's very, very widespread, it's well thought out, and it just allows you to do quite a bit. And you have to share the source code and things like that, which is perfect. And since so many people use it, it means it's very compatible with everything else everyone does. There is some very, very permissive licenses like the BSD license, and that's basically it's very short and it's do whatever the hell you want, basically. Um, and there's a few little variants of that as well. So, you go from one extreme to the other. And then the other kind of extreme is if you use this license, then it kind of infects everything that you use downstream. And it kind of has this difficult to use. It's more political, it's where people really want to say, okay, if you use my stuff, then all your stuff must be open source. Whereas others are like, well, you can use my stuff, but as long as you don't modify it or whatever, you're fine, And
Mm,
so it can get very difficult, and you have to be very, very careful. In some cases, some licenses they can be dangerous, in how they force certain things that you don't necessarily want. Like, if it's a very permissive license, if it's a license that kind of affects other software, um, license wise, then you have to be careful, because if you apply that to yours and then it applies to others and others and others, and go, it's kind of has this house of cards effect, and you have to be so careful.
yeah, that's a good like just banner for folks. Like, not all open source is created the same, but there are some nuances between. There are some really commonly used ones, like the ones you've mentioned. But it's worth being on the lookout. Like, not whenever you're looking to adopt software, fork software, make modifications. A huge protection too against open source software that gets integrated into maybe like a commercial software. So like there's a ton of restrictions of like, hey, I forget exactly which ones, but if you're going to use my open source software, it can't be brought into a black box proprietary commercial use case, and we see that a ton. And I think
Yes.
what we're oh, go on, sorry.
Yeah, so I think one of the big changes has been GPL2 and GPL3 was the TiVo kind of exemption. And so TiVo, back in the day were producing these TV boxes. I think they're still around, but TV boxes, for recording live TV. And they were using open source software, but they weren't distributing their changes or whatever, because it's just a black box, and basically that's it, even though they're getting all the benefits of open source. So then they brought in changes through GPL3 to kind of force anyone who in that situation to actually share the modifications, share the software, which is good.
Yeah,
But then some people make it so difficult. It's like, send me a letter to this address and I will post you back, 200 floppy disks with the open source software. You occasionally see, kind of websites where it's like, if we're open source and you just have to fill in this form with all your details and email us, and we'll think about it for 2 weeks. And I know some old papers, they're like, post us a letter and we'll send you back a tape, like, these old school tapes, which clearly isn't the ideal format, but
yeah, yeah, open source with quite a gate to get into the door there. But okay, so and I think what we're talking about generally is the workflows themselves that you and I are used to writing in terms of what we're posting on GitHub and the repositories. But another conversation is the platforms that coordinate and execute and run these workflows. So now I'm thinking about resources like maybe CLC, the Genomic Workbench, that is this proprietary suite that gives you access to open source workflows, or something like IRDA in Public Health Canada that came out of a lot of the works up there, or Terra, a platform you and I utilize quite a bit, and other, there's a number of these different things. Sakara platform is probably another one worth talking about. How do you distinguish the open source utility in workflows versus platforms? Because all the workflows we talked about, need to be accessible, interoperable, all these other things. What's your thoughts on platforms?
yeah, that's a very difficult one, because sometimes the platforms are open source themselves, but they're so tied to the infrastructure that they're built upon in an institution or whatever, say like Terra, that there's no possibility of it ever being run outside of that organization, because there's so many components, so much, fine-grained configuration, and it's that configuration, that data that is critical that you need, but they can't share it for security reasons, because it would show their internal system structures. And so it's this kind of challenge to be able to have platforms. Say Irida is very open and you can run it anywhere. It's like you drop it in, it runs, and there's a little bit of configuration, but fundamentally it's not tied to one infrastructure. Whereas Terra, it's never going to be run outside the broad, and that's not a bad thing. All the software is there, all the major components is there, and you can download them. There's long lists of them, so you can take components and build bits of your own, but you're never going to run another Terra system itself. And this applies to many other systems as well. Some keep them for commercial purposes; they keep them private. Others for security reasons. If you want that provenance and you want to say absolutely, this data has gone through these steps and we can guarantee it, and got all this security in place, for whatever validation, or for protecting into patient identifiable information, that kind of thing. Sometimes there's legitimate cases for it. But platforms is a difficult thing, and journals do recognize that. So for some journals, for software publications, they will allow platforms and software like websites to be kept closed source, where even though they're free to use and they're technically not really reproducible.
And the reproducibility is the biggest thing. And I think, and we talked about IRDA, and it's really built off Galaxy. And Galaxy, again, is one of those things that's super open source. You can create your own instance. You can set up everything outside of, what's hosted for the general Use Galaxy project, which I believe is still over at Penn State or maybe Texas or something like that. But the reproducibility is the big thing. And I think that's what draws the line in terms of the absolute need of the full open source capability of the platform, because something on Sakara Tower or even Terra are really good examples, whereas those aren't necessarily platforms that I can see the open source code, do some git clone, and I have an instance of Terra, or I have an instance of Sakara Tower. That's not true. But the workflows I can run outside of Cetera. I can run outside of Cetera platform, and I can still have that reproducibility. So you still have that level of transparency, interoperability, reproducibility, even though the platform itself that coordinates all the sort of back-end data management, security, federated, back-end and things like this, those are maintained by the platform itself. So I think that is worthwhile distinction when we're discussing this. And um, beyond that, maybe in the last couple of minutes we could talk about what are the challenges in a strictly open source world when we're talking about public health, pathogen genomics, or even maybe the software world at large.
Yeah, I guess, well, one challenge is it's actually quite difficult to make software that is open source and other people can run and download and run anywhere. That's like, that's an enormous challenge. We could talk all day about that, And so you have to have your software, actually built properly so other people can install it and run it. And you have to figure out dependencies and things like Conda do help and Docker does help and things like that. So, that's a huge challenge that a lot of people don't get. And you do occasionally, you'll come across, particularly if you're reviewing software, you come across like people writing these dodgy bash scripts, 500-line bash script that no one could ever possibly run anywhere other than the person's laptop who wrote it. And it's a challenge, so it's a skill to write good quality open source software. And it's not just the software itself, it's the documentation, it's how it's written, it's example data, it's, have they thought out how data goes in and out, and is it actually solving the use case that most people want? That you do occasionally find where people have got a very bespoke solution and they take in an obscure file format and pump out an obscure file format that no one is ever going to use. Whereas they could just use the standard file formats, in and out, and that would actually make it more usable. And of course, more usage means more people will cite it or reference it, so that's a
Absolutely.
challenge.
Yeah, that, and then also the maintenance of those types of resources becomes a big challenge. And not only does the onus is on that first open source developer to put it out. Hopefully, it's something that's usable, readable, legible by other developers. But then, as soon as public health laboratories start incorporating it, you're hoping there's some level of continued support and maintenance, which is not always the case, right? By
No,
contributing to the open source world and by being a consumer of the open source world, that's not part of the contract necessarily. So that becomes, and there's not necessarily always grant funding for like, hey, I'm going to support the tool that I built 3 years ago. It's hard to find. I don't know many resources where that they make that the case, but yeah.
I mean, that's supporting software that I wrote nearly a decade ago, and it's in use in production. Public health labs use it, but I was only paid to write it originally, not to support it, and I've moved jobs multiple times in that period, and it's a challenge. Most of this, a lot of software is created by academics. Most academics, will move on, might finish a PhD or postdoc. That's it. There's no onus on them to support it. But yet, then in public health, we need stuff that's in production, and we need it to work, and we need things to be fixed, and that's a challenge, because you need that ongoing support and maintenance, and yet the people who created it are probably long gone, and that's
Yeah.
that's why you have such short shelf lives for open source software, particularly in bioinformatics. The average shelf life is maybe 2 or 3 years. Basically the length of a postdoc or length of a PhD.
Yeah, and we can end on this point here because in that challenge, it really necessitates the public health lab to have somebody or access to somebody in the technical community who can kind of vet the software. Like this one's solid. This is going to be a good use. We can incorporate this to our public health lab. So that is its own kind of barrier relative to a proprietary software. You just purchase it, and there's a company behind it that's going to support it long term. There's agreements in that play. And the last thing I just wanted to say about that specific challenge is where organizations like Phage, or I know in our working group, we're trying to create what are those standards? Can we, as a community of technical practitioners, identify open source software that have been assessed and looked at by different technical practitioners to again lower that barrier for people implementing these software? It'll receive this sort of Phage batch or badge or check of approval of like, no, this is solid for public health bioinformatics, and it could be used even though it's an open source or that resource that might not be maintained long term. But as always, we can go on and on with this, so we can end things there unless you want to say a final word on open source software
Nope.
and public health.
I think we talk all day about this.
All right, cheers. We'll see everyone in the next one.